quantum entanglement, a quirk of quantum mechanics that is so complicated that even Albert Einstein admitted that he didn't understand how it works. They were able to transport the particle 3.8 miles at faster than the speed of light. Now, quantum entanglement can enable travel faster than the speed of light because in the world of quantum mechanics, a particle can have a physical effect on another particle because they are entangled with one another, no matter the distance between them. There is a more immediate, game-changing use for this discovery. It could lead to quantum networking. Using the same quantum entanglement methods, we could theoretically create a brand new global internet network with zero latency. When you send an email or instant message to a friend in another country, there is a small but noticeable delay, anywhere between 20 to 1000 milliseconds, before it reaches them. This is because the photons of light that carry the data you just sent have to physically travel through fiber optic cables, possibly across oceans and continents. A quantum internet would be instantaneous, opening a new realm of possibilities for internet security, medicine, military, and many other applications. And of course, internet gaming would be an absolute dream with zero lag.
So I just want to mention that that video I showed, I'll leave a link down below to it, but they grossly misrepresented quantum internets. I got videos in the past that it gets a lot more detailed into this stuff, but I figured I might as well make a quick digest so anyone who's curious about this can easily pick up and see where we're going. Keep in mind, this is my background. One thing I note is, and it's very important to note this, is how quantum entanglement works. Is you basically got two particles and they will be entangled with each other, and not getting too deep into that, but you cannot take another particle and say, oh, I'm going to entangle into this. No, it's just these two particles and that's it. So, and keep in mind that you can have more particles there, which is fine, but which is basically, instead of you having just one set of two particles, so it's 1 and 0, you're able to take another set and do, add more so you can actually get higher speed. But basically you can't just say take this particle and say, oh, I want to entangle it to something else. It's very important to note that, and I'll explain how the system works through this diagram. So as far as things goes, this is just a simple paint short job. So let's just say that you are here, your modem's here, ISP's here, and all the way on the other end you got your modem, and then your other end maybe a web server or whatever it may be. So with here, your connection between yourself and the modem is going to be the same as it is. It might either be through Ethernet or wireless, or wherever it may be. And the same thing with the other side. So the web server or someone else, it might be through Ethernet or through radio towers or something like that. There's not going to be a quantum thing on your actual device, your laptop, your TV, or whatever it may be. Then I'll explain a little bit more on this in a second. But what's going to end up happening is your modem itself, it will translate the data into quantum. See, the thing with quantum is you don't actually need to have wires. Like once everything's set up right and we actually know exactly how this is going to work. Keep in mind, the cost of this right now, it's a bit much, and militaries will be able to use it just fine, and a few others will be able to use it just fine for a number of years ahead of time. And a lot of this equipment takes the size of an entire room to run, and you can't have that on a residential site. So it'll be a number of years before we see this. So by the time it gets there, you don't need the wires anymore. But what will end up happening is basically your modem itself, it will actually translate the data from your whatever you're sending from normal to quantum. So it transfers from there. And through the quantum world, not getting into the science behind that, there's plenty of videos out there on this, it will actually go and connect to a entangled pair with your ISP. Your ISP will then transfer back that into a normal understanding. And what would that do is the ISP, it will see where the route needs to be directed to, because by them observing the quantum entanglement particles, it will actually change it so it can actually route it to the wrong place or corrupt the data that's coming through. So it has to transfer it back into a normal signal, and then from there it figures out where it needs to go, and through the normal routing and switching, it will actually go and say, oh, it needs to go to this place over here. Well, from there it will change it back to a quantum, and the routing and switching will figure out which is the best hop to send it to, the quickest hop to send it to. Because keep in mind, overload and whatever it may be, you have everybody using one single thing, it's going to overload it. So, it's just best, which is the best to go through, or what do they have license to go through and stuff like that, what's up and whatever. So from there, it will try to send it through, and it'll have a quantum entanglement particle that's connected to all whatever it may be, and it will keep going through the hops where it again transfers back into a normal signal, understands where it needs to go, transfers back into the quantum, and keeps going through these hops until it gets to, say, the ISP. Let's just say that this is the ISP. Well, the ISP on the other end, the web server or whatever it may be, the internet service provider, what would end up happening is it will then figure out, oh, it needs to go to this person, so it will transfer it back to quantum, and then it will go to the modem, and then it will transfer it back to normal signal, and everything else be normal. So what you will see on your end is, oh, I need a special modem to work with my ISP, my internet service provider. You don't need unless it's the router, the Wi-Fi router they want you to play with. If that's, here's the thing. As a network person, I will recommend never, ever, ever use a Wi-Fi router that your internet service provider can control. A modem, fine, whatever. There's not much I can do that in the first place. But what you need to basically do is note that you will have to take a modem to actually from the ISP that's connected to the ISP, and that's the only thing that needs to be switched out. Now, why wouldn't you have, say, your laptop or your TV or your phone directly connected to the ISP through the quantum entanglement? Well, again, you can only pair one particle with another. So what this basically means is, let's say your ISP goes out of business. Well, then you're going to have to change out all your laptops, your TVs, and all your other stuff in order to get back on the internet. You probably see a problem there. I think a lot of people get PO'd by having their laptops and whatever have to be changed out versus a simple modem. Because you change out a modem, that's going to be no problem into itself. Change out a laptop, whatever, you got to deal with data and all this other stuff, and that's just not fun. And you might be saying, well, why not deal with a NIC? Keep in mind, you got phones and TVs and stuff like that. That's simply, it needs to be able to connect to the internet. You got legacy items and a few other things. And stuff like TVs and stuff, how are you going to change that on that device or your phone or your tablet? It's just not going to happen. In most laptops, you cannot do that nowadays. Maybe desktop's fine, whatever. But all this other stuff, it ain't going to happen. So you're not going to be able to simply change out a part. And some people might say, well, what about SIM cards? It will be a very, 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 very long time before the technology gets to that point where you can fit it down to that level, mostly because you got to keep it very, very cold. It's just, simple fact is I don't think that it will ever get to that point. I think basically your device will always connect to your Wi-Fi router or router, depending on how your setup is, or switch or whatever. And basically from your device to your router, that will be normal. Your router to your modem, that will be probably through Ethernet cable, and then your modem there on out will be different. For those of you who don't know, in networking, we call this the last mile. the last mile is probably always going to be the same. Obviously, with different technology to make it a little bit faster and whatever it may be, but I don't think there's ever going to be a, entangled particles within this area other than the modem going out to the internet service provider. Because the simple fact is again, would you prefer to change out a $20,000 web server because it doesn't connect to your ISP because they want to hold it hostage, or because they go out of business, or whatever it be, or would you rather just change out your modem and go from there? Oh, and I forgot to mention, the thing to note is where he said that there's no lag at all. That's not true at all, because remember, you have to connect from your device to your router, and the other side has to do something similar. And with that, there's going to be some slight lag, but you take out a whole huge amount of lag when you get into taking out wires and stuff like that. But still, even ISPs, it has to translate it back into regular signal, then back into quantum, and each one of these is going to add some slight lag, but you're talking about maybe a millisecond, if that. So it's going to dramatically lower the lag. For you to see it, it's going to be no lag, but all technicality and whatever, if you're on the networking side of things, there's going to be some slight, ever so slightly lag. This is fairly important because if someone is tapping into a network, say for example, right here where let's say that you have a hacker that goes into it, any of these hops really, and basically as the signal transfers into quantum, into normal, and when it figures out what it's going to do with the normal, if you have a hacker that's going into here, it will actually add a little bit more lag. This is actually what the NSA uses to figure out if someone is tapping into their systems, because they actually have sensors between certain points, all the way up to a given point, and it always measures lag, and if lag drops below a given tolerance point that they know about, it's secret and whatever, then alerts go out. They figure out exactly within a couple meters of where the problem is. They see if it's a backhoe that nicked a cable, or if it's something more. But that's where things come into play. So for networking people, there is going to be a lag. For you, okay, you can say whatever you want for marketing terms.